In 2019, Elon Musk made a prediction that sounded almost unbelievable at the time. He suggested that Tesla could have a large network of autonomous Robotaxis operating on the road. Not someday in the distant future, he was talking about a relatively short timeline. Years have now passed. Tesla has continued developing its full self-driving technology, artificial intelligence, and autonomous driving systems. But the question is simple: how close did Elon Musk's prediction actually come to reality? Was the vision completely wrong? Was it simply too early? Or are we watching the early stages of something Musk predicted years before the technology was ready? Today, we are going to look at the prediction, what happened afterward, where Tesla stands now, and what could happen next. To understand the story, we have to go back to 2019. Tesla was already investing heavily in autonomous driving. The company had cameras, neural networks, onboard computing, and millions of miles of driving data. But Musk wasn't simply talking about a car that could assist a driver. He was describing something much bigger. A future where Tesla vehicles could potentially operate as autonomous taxis. A Tesla owner could theoretically allow their vehicle to participate in a network. When the vehicle wasn't being used by its owner, it could potentially provide transportation services. In Musk's vision, the vehicle wouldn't simply be a CAR.it, could become an income-generating asset. That idea became known as the Tesla Robotaxi concept, and this is where the first important distinction appears. Musk was describing a future system. He wasn't simply predicting that one Tesla would drive itself from one location to another. He was imagining an entire transportation network built around autonomous vehicles. That is a much bigger challenge. Why did this prediction attract so much attention? Because if autonomous vehicles actually become reliable at scale, the economics of transportation could change dramatically. Think about how a traditional car is used. Most of the time, the vehicle is parked. It may be used for commuting in the morning, driving home in the evening, and perhaps a few additional trips during the day. For the rest of the time, it sits unused. Musk's idea was different. If autonomous technology became sufficiently capable, a vehicle could potentially spend more of its time transporting people. That could increase the usefulness of each vehicle. And for Tesla, there was another potential advantage. Tesla already had millions of vehicles on the road. Those vehicles could potentially provide enormous amounts of real-world driving data. That data could then be used to improve AI systems. This created a powerful feedback loop: more vehicles, more driving, more data, more training, potentially better software, and potentially more capable autonomous driving. At least, that was the theory. There was just one problem. Building a vehicle that can drive itself in controlled conditions is one thing. Creating a system that can operate safely and reliably across millions of real-world situations is another. Roads are unpredictable. There are pedestrians, cyclists, construction zones, unusual intersections, poor weather, temporary road markings, unexpected behavior from other drivers, and countless situations that are difficult to predict in advance. This means autonomous driving isn't simply a matter of making a computer better at following a road. The system has to interpret its surroundings and make appropriate decisions across an enormous range of situations. That's why progress in autonomous driving has taken longer than some early predictions suggested. And this is where Musk's original timeline becomes important. The vision remained largely intact, but the timetable became much harder to achieve. So let's separate the prediction from the progress. Tesla did not simply stop working on autonomous driving. Quite the opposite. The company continued developing full self-driving software and investing heavily in AI computing. Tesla also continued collecting driving data from vehicles equipped with its hardware. At the same time, the company increasingly presented artificial intelligence as a central part of its future. This is important because the original Robotaxi vision didn't disappear. Instead, the path toward it evolved. The technology became more sophisticated. The AI systems became more important, and Tesla's strategy increasingly connected autonomous driving with robotics and artificial intelligence. So if we judge the prediction by its original timetable, the result is difficult to call a complete success. But if we judge the broader idea, the picture becomes more complicated. The technology moved forward. The commercial model was not fully realized on the original schedule, and the final form of the system may look very different from what people imagined in 2019. There are several possible reasons. The first is technological complexity. AI systems can become dramatically better without suddenly becoming perfect. Autonomous driving requires extremely high reliability. A system can perform impressively in thousands of situations and still encounter difficult edge cases. The second challenge is regulation. Transportation is heavily regulated. When software takes on more responsibility for driving, governments and regulators need to determine how these systems should be tested, monitored, and approved. The third challenge is public trust. Even if the technology improves rapidly, people still need confidence in the system, and transportation companies need to demonstrate that the technology works consistently. The fourth challenge is economics. A robotaxi network isn't just software. IT requires vehicles, maintenance, charging infrastructure, insurance, customer support, and an operating system capable of managing a huge network. So the real challenge isn't simply, can Tesla make a car drive itself? The bigger question is, can Tesla build an entire autonomous transportation business around it? That's a much harder problem. This is where the answer becomes interesting. If we judge the prediction strictly by the original deadline, it is difficult to argue that the original vision arrived exactly when predicted. But calling the entire idea wrong would also be too simplistic. The underlying technology has continued advancing. Tesla is still investing in AI. Autonomous driving remains one of the company's major areas of development, and the idea of autonomous transportation has not disappeared. In fact, the broader industry has continued moving toward it. So perhaps the better way to describe Musk's prediction is, the vision was ahead of the timetable. That distinction matters, because predicting the future isn't only about predicting what will happen, it's also about predicting when it will happen, and those are two very different challenges. Now we reach the most interesting part. What if the robotaxi prediction isn't really the final goal? What if autonomous driving is only one piece of a much larger strategy? Think about the technologies Tesla is developing: artificial intelligence, autonomous vehicles, robotics, energy, computing. These areas can potentially reinforce each other. A better AI system could improve autonomous driving. The same advances in AI could potentially help humanoid robots. More robots could create new demand for AI computing, and autonomous transportation could create an entirely different way of using vehicles. This means the robotaxi story may not simply be about replacing traditional taxis. IT could be part of a much larger attempt to make physical machines increasingly capable of operating with less direct human control. That is a much bigger vision, and it is also much harder to predict. So, how close was Elon Musk? If we are talking about the original robotaxi timeline, not as close as originally predicted. If we are talking about the broader direction, the story is still developing. Tesla has continued investing in the technologies required for autonomous transportation. The original vision has not simply disappeared, but the final result may take longer, cost more, and look different than Musk originally expected. And that's perhaps the biggest lesson from studying Musk's predictions. Some predictions are surprisingly accurate, some arrive later than expected, some change along the way, and some remain uncertain for years. That's why the interesting question isn't simply, was Elon Musk right or wrong? The better question is, how close was reality to the future he imagined? And on Robotaxis, the answer is still being written. Elon Musk has made dozens of ambitious predictions about AI, robotics, transportation, and space. Some have moved closer to reality, others have taken much longer than expected, and some remain impossible to judge today. In the next episode, we'll look at another prediction and compare Musk's original words with what actually happened. Because sometimes the most interesting part of a prediction isn't whether it comes true, it's discovering how the world changes while we are waiting for it to happen.